All right, this section is on graphs, transformations, and solutions. And this is going to build upon what you all have already learned about transformations of a graph. So let me show you a quick example. So we all know this function is a parabola centered at the origin. But if I changed that to x plus 3 squared, what would happen to the graph and all of the values of that function? This plus 3 here attached to the x means that I would shift all of the x values to the left 3. So if you remember, it's always opposite of that sign. So we're going to talk about that, not just how it affects the graphs, but more specifically how it affects the solutions of equations. So when we replace x in an equation with x minus h and y with y minus k, remember it's the opposite happening, and we actually shift all of the x values to the right, and we would shift all of the y values up k units. So you'd shift right h and up k. So that's how we know that it's the opposite as that sign. Now we're going to use transformation notation. So the notation for actually representing that transformation is capital T, x, y. So this is telling us what we're transforming. And the arrow over, so it's transforming x and y. And then for the transformation notation, you actually write what's literally happening to the x values, and we're adding h to them because we are shifting them right, and to the y values we are adding k. So it's important to understand the difference between these things, and those are what's in the equation itself. Transformation notation is what's actually happening to the values, so it's opposite. So this is x minus h, which tells us to shift right h. So in transformation notation, we add the value of h to all of our x's. And one other type of notation that you may see, I think you'll see it on your homework, sometimes instead of seeing this, you'll see capital T and then just a lowercase hk. And that's telling you what to add or subtract to all of your x values here and your y values there. So next we have scale changes, and that is when instead of having plus or minus with x and y, you've got something divided. X and y are divided by or multiplied by a number. So when we replace x with x divided by a and y with y divided by b, then we change the horizontal magnitude, meaning we're going to stretch this by multiplying all of the x's by a. Multiply x's by a. So that's what's changing horizontally, which affects our x values. And then if y is being divided by something, we are vertically changing the magnitude by multiplying all the y's by b. So this still should be mostly review. So again, when we do this, in the equation itself, it will be x divided by a. But since the rule is telling us then to multiply, the transformation would be t, or you might see an s there sometimes. So I'll do that for scale change. And then you'll have xy, arrow over, and this right here is telling us to multiply all the x's by a and to multiply all the y's by b. And you might see a scale change like this. You even might just see it like this. So that denotes scale change. This is what you do to the x's, multiply by a. That's what you do to the b's, multiply by, or the y's, multiply by b. Okay, on this first example, first we're just going to graph this function, y equals x cubed. So we take our x values and cube them. So 0 cubed is 0, 1 cubed is 1, 2 cubed is 8, and Negative 1 cubed is negative 1. Oops. And negative 2 cubed is negative 8. So then we've got a rough graph that looks like that. Then it says, on the same grid, graph g of x. So we're going to graph a new one. I'm just going to write y equals x minus 2 cubed. Well, if we already know that the parent function, which is this function, looks like this, then we know that this function should be the exact same, except all of the values should be shifted right too. Since it says x minus 2, we will do the opposite of that and shift all of our values over to the right 2. So I'm just going to each individual point and shifting them over 2. So here's the graph of g. So how are the zeros of f and g related? The zeros are where the function crosses the x-axis, where the y value equals 0. So here's the 0 there, here's the 0 on g of x. Those are related by simply the first one, the parent function, is shifted over 2 to the right. So they're shifted 2 units. So all of the points are shifted 2 units right. The reason we're focusing on the zeros is because 0 is another word for solution when you set the function equal to 0. So we're going to be looking at how to find solutions of functions by using the transformations that we've learned about. So it's asking what chunking statement could have been set up, meaning back in this original g, we know that if we let t equals x minus 2, then you're really just looking at the function g of t equals t cubed. Since we know what t cubed looks like and that its solution is when it equals 0, its 0 is 0, 0, then to find the solution of this, we would just shift that solution over to the right too. So use transformation notation to show the relationship between the two solutions. So the transformation notation that gets us from here, the zeros from here to the zeros to there, capital T for transformation. What are we transforming? X and Y. And what do we do? What is the rule that we should apply to all of our x values? That is add to. So it's opposite of that. This is the actual rule we are adding to. What did we do to all of our y's? We didn't do anything to our y's, so you just write y and you use the same y values as before. So if we want to use this transformation to apply the zeros of our original function to find the zeros of this function, we would write, so what two x and y values, or what x and y value are we transforming? We're going to transform 0, 0, because that's the solution, or the 0, on our parent function. So we add 0 plus 2, and our y value is just going to stay 0. So the solution to our new function g is 2, 0 right there. So this is it's breaking down a very simple problem so that hopefully it will make sense when we do more complex problems. Alright, so we're going to take a look at a little more complicated example here. So now we're going to graph and solve this inequality. And graphing this inequality, it's fine to just use your graphing calculator. So graph it and find some values that are graphed on coordinates that are easy to find. So we would find first we've got a coordinate here at 1, 0. We've got one at 2, negative 2. We've got one at 3, negative 2. And 4, 0. We've got another one at 0, 4. And 5, 4. So here is our function our parabola graphed there. Now, this is just, this is the parabola, but remember the equation isn't even an equation, it's an inequality. And the inequality is asking for when this parabola is less than 0. So when is that parabola have a negative value? And we can see from the graph it's negative from 1 to 4. But let's solve that algebraically. And solving this inequality algebraically is going to require a new method that you guys haven't seen yet, I don't think. And now typically when solving something like this, if this was an equal sign right here, you guys would say, oh, that's a quadratic. I can factor that, hopefully. And here we can. What multiplies to 4 and adds to negative 5? X minus 4, x minus 1. Now, if this was an equal sign, then you would say the solutions are 4 and 1. With an inequality, it doesn't work the same. If you have the product of two terms and an inequality, the solutions aren't just the opposite of what you see here. Now we need to use something called the test point method. Test point method. And to use the test point method, you pretend this was an equal sign. What would our solutions be? Our solutions would be 4 and 1. So to use the test point method, take those two potential solutions and plot them on the number line. Now it's called test point because we are going to be testing points in each of the 3 intervals that we just formed. Everything less than 1, between 1 and 4, and greater than 1. And we're going to see, are the products of these two things positive or negative in each of those intervals. We want them to be negative because that's what our original problem said. So you pick a value less than 1. In this case, I would choose 0 because 0 is easy to work with. Plug it in here. When you plug 0 in, you get negative 4 times negative 1. The product of that would be a positive value. That's all we care about. Will the product be positive or negative on that interval? And it would be positive. Now we want to know, what will the product of these two things be between 1 and 4? Pick something between 1 and 4. So let's pick 2. Plug 2 in here, you get negative 2. Plug 2 in here and you get a positive. So a negative times a positive is negative. So anything on this interval, any x values you plug in here, you're going to get a negative product. Lastly, pick something greater than 4, so 5. 5 minus 4 is positive, 5 minus 1 is positive. That means their product is positive. So now we know what the product of this will be for any x in these intervals. What we were looking for is when the product is less than 0. The product is less than 0 between 1 and 4. And because that's strictly less than, we don't include 1 and 4. So we know our solution is 1 to 4, not including 1 and 4. Now again, we saw that on the graph. We won't have the graph in the future. This is just showing you a visual of what's happening. This is what you'll be using to solve problems like this. So we see that the solution is when x is in between 1 and 4, that function is negative. So the next step here is saying to, on the same grid, graph this inequality, which looks crazy, but if you relate it back to our original inequality, you can see that the only difference is that instead of x, you've got x plus 3. It's still minus 5, x plus 3 plus 4 is less than 0. We know that that x plus 3 means that every point on our original graph here will go in the opposite direction of what this is saying. So in the equation it's plus 3. That means we shift all of these coordinates left 3. So go ahead and do that. So we're shifting everything to the left 3. When we do, we get this new parabola. And it's asking how our, oh, it says solve using chunking and the test point method. Well, that would just mean instead of writing this whole thing out and solving for x, we can chunk, let t equals x plus 3, and you've got t cubed minus 5t plus 4 is less than 0. We already solved that. We solved it right here. So we know what our solutions of that are going to be. T is between 1 and 4. But what is the transformation that happened here? So this is the most important part. The transformation that happened, so here's the transformation notation. We transformed x and y, and how did we transform them? What is the actual rule that we did with all of our x values? Now here it says plus 3, but we did the opposite. We actually subtracted 3 from x's, and we did not change the y's. So if we know the solutions to this to that inequality, which we know is everything between 1 and 4, then the solutions to this inequality is going to be exactly the same except applying this transformation on the values. So we know that instead of this solution, we're going to take our x values, which these are both x values, we're talking about an x interval, and we need to apply that transformation. So the solution to this inequality, we're going to take 1 and subtract 3, that would be negative 2, and take 4 and subtract 3 to get 1, which is where you'll see is true on the graph right here. We're below 0 when x is between and not including negative 2 and 1. So we left some of these blank. It said how are the solutions related? Shifted left 3. So the chunking statement that we set up here was let t equal x plus 3, which we already knew. Okay. All right, on this next one, I'm actually not even going to use the graph because I want you guys to get out of the habit of relying on it to find these solutions. So the first thing is saying graph and solve this inequality. So we're going to just solve it. We're going to first just solve x squared minus 2x minus 8 is greater than 0. So what? Now if that was just an equal sign, we would factor. When is that greater than 0? So what multiplies to negative 8 and adds to negative 2? That would be minus 4 plus 2. So here we have a product of factors and then an inequality. So again, we need to use the test point method. So if this was an equal sign, we would just say the solutions were 4 and negative 2, but it's not an equal sign. It's a greater than sign. So we need to use the test point method and test the 3 intervals formed when we plot negative 2 and 4 on a number line. So pick a value less than negative 2. So we're going to test this interval right here. So pick whatever you want, say negative 10. If you add 4 to negative 10, you're still negative. And you add or subtract 4 from negative 10, you're at negative. Add 2 from negative 10 to negative 10, and you're still negative. So a negative times a negative is a positive. Now pick a value between 2 and 4, negative 2 and 4. Always pick 0 when you have the opportunity. Plug 0 in, you get a negative times a positive. That product will always be negative. Pick a value greater than 4, so 5. Subtract 4, you're positive. Add 2, you're positive. So a positive times a positive is a positive. Which intervals do we care about? The ones that are greater than 0. So our solutions to this inequality are anywhere on these two intervals, which is anything from negative infinity to negative 2. Now I'm not including negative 2 because it was strictly greater than. Union not including 4, to infinity. Those are our solutions to our original inequality right here. Now look down at this inequality. This looks intimidating to solve. So in the future, I won't give you this. You'll see something like this. But if you can chunk or substitute, let t equal x over 5, then you'll solve that for t just like we did here, and then using a transformation rule, figure out what you need to do to these solutions to get the solutions to that more complicated inequality. The transformation used here. Now, x is being divided by 5. That transformation is a scale change. And it's really saying that to all of the x's, you need to multiply by 5. And what are we doing to the y's? Nothing. Again, it's the opposite of what's happening in the equation. So this is the actual rule times 5. So that means if I want to know my solutions to this, because I already know the solutions to that chunked version of it, if I just solve the parent function, all I need to do then is multiply all my x values by 5. So the solutions to this equation, inequality, multiply my x's by 5. Well, these are all x values. What's negative infinity times 5? Negative infinity. Negative 2 times 5, negative 10. Union, 4 times 5 is 20. Infinity times 5 is infinity. Here's the solution to this more complicated inequality that we just used a transformation. Instead of solving this, you can solve the simpler version of that to get the inequality or the solution for the more complicated version. Okay, so here is a better idea of what you guys will be needing to do on your own. So if you look, this page is split into 2 columns, left and right. On the left, it's just a simple equation or inequality that you all should be able to solve. On the right, it's a more complicated version of that same equation or inequality. So we're going to solve this simpler form, identify the transformation that's happening, and then use that transformation to apply the solutions to the more complicated version of it. So let's look at 4. Now if I was solving this for x, I would add 8 to both sides. You get x cubed equals 8. Now cube root both sides, and the cubed root of 8 is 2. So our solution to this inequality is x equals 2. Now if you look right here, you have x plus 4 cubed minus 8. Now instead of going to solve this the way we've learned how to solve equations, if we know the solution to this, and we can identify that the only change from this to this is that everything, all of the x's, are really being shifted by 4, then we can just shift this solution by 4. Now we have to figure out what direction we're shifting and write the transformation. So identify the transformation. So using transformation notation, the transformation on x and y, what are we actually doing to the x's? We would be moving them left 4. So that would be x minus 4, comma y. So that's the transformation. That means our solution would be the same as this, only shifted left 4. So 2 minus 4, which means our solution here would be negative 2. Let's look at this one. Now, e to the x equals 5. How do I get that variable x out of the exponent? You would take the natural log of both sides. So natural log of e to the x equals natural log 5. Well, we know that this x comes down, and the natural log of e is just 1. So x equals natural log 5. And you can just leave it in terms of natural log. Now if you look at this one, what is the difference between this equation and this equation? The only change that you should identify is that instead of e to the x, you have e to the 2x. So what is the transformation? If I'm multiplying the x by 2 in the actual equation, then the transformation, remember the actual rule that you're doing isn't multiplying x by 2, it's dividing x by 2. So it's always the opposite of what you see in the equation. That means if my solution here is natural log 5, then my solution here, x, is going to be the same as this, only divided by 2. So x equals natural log 5 divided by 2. All right, a couple more here. Now, if we were solving this equation here, number 6, how would I solve that? Well, since I just have a log equals a number, I'm going to rewrite this as an exponent. So the base of my exponent is 2, the power of my exponent is -3, and that equals x. So 2 to the negative third is the same as 1 over 2 to the positive third. So x equals 1/8. That is an 8. Okay. Now looking at this, what is the difference between this equation and this equation? This one is a little trickier because you have a couple things happening. Instead of log of x, now you have log of x plus 1 divided by 4. Two things are happening. X, you add 1, and then you divide that whole thing by 4. What's important to remember here is that you always do scale changes first. Scale changes first. That means the first thing we're going to do is multiply by 4 and then subtract 1. Again, remember, if this is the rule, if this is telling us in the equation if it's plus 1, we're really subtracting 1 from all the x's, and this divided by 4 means we're actually multiplying. So what's really happening here, the transformation is, well, there's two things happening. The first one is multiply by 4. The second one is, and you could just do this all in one step, after you multiply by 4, you subtract 1. Whoops. 4x minus 1, comma, y. This is the transformation that's happening here. So our solution right here, we need to multiply by 4 and then subtract 1. So 4 times 1/8 equals 1/2, and then we're going to subtract 1, and you get x equals -1/2. Okay, and our last example, x cubed minus 25 is less than or equal to 0. First thing I would do in solving that is factor out my greatest common factor of x. And then you've got x squared y, x times x squared minus 25. So if I was solving this, remember, if this was just an equal sign right there, I would solve x equals 0, and then I would do this factor, which is x squared minus 25 equals 0. X squared equals 25. So I'd get x equals plus or minus 5. So I have 3 solutions here, 3 possible solutions. Now I'm going to have to use the test point method, but now I need all 3 of these on my number line. -5, 0, and +5. This means I'm testing 4 values now. So pick a value less than -5. So say I pick a very large negative value. If you want -100, that would be a very negative number. Square that negative number, and it becomes positive. subtract 25, still positive. So that means I would have negative times positive, which is negative. If it helps, you can think of this in terms of x times x plus 5 times x minus 5. So if I pick a value between 5 and 0, so say I pick negative 2, that would be a negative value, positive value, negative value. So if you need to, write this down, negative, positive, negative. When I multiply those three things together, these two negatives would make a positive, times a positive gives me another positive. Now if I plug in something between 0 and 5, so say I pick 1, then I would have 1, which is positive, add 5, positive, subtract 5, negative. So the product of those three things would be negative. And then pick something larger than 5, and I would have positive, positive, positive. So what am I caring about? Everything less than or equal to 0. So this interval and this interval. And because it's less than or equal to, I can include these values. So our solution to this original inequality, negative infinity to negative 5, and 5 to infinity. Now if we look at what's happening here, the transformation that changed this to this is just this minus 4. Well, the actual rule that we will have is transformation on x and y is, since it's minus 4 in the equation, it's x plus 4 and then y. So all I do to these is add 4 to all of my x values. So negative infinity plus 4 is still negative infinity. Negative 5 plus 4 is negative 1. Union 5 plus 4 is 9 to infinity. So we've applied this transformation to our solutions from this inequality. And that's it.